Okay, today we are going to talk about how to solve logarithmic equations. I don't have the video part turned on because the sun is really bright behind me and you can't see me. Plus I look really awful because I'm tired. So we're going to quickly get through this and then we will talk about this again in class tomorrow. So make sure you take notes over this, write down the steps especially in the examples so that you kind of know what's going on. Alright, here we go. Solving log equations. You kind of already know the steps for doing this. And it involves doing the loop trick that we learned before spring break. So hopefully it won't be too difficult and hopefully you'll kind of get the hang of it pretty quick. Okay, so steps for solving logarithmic equations. First, you need a condensed log, meaning it needs to be one log equals a number on the other side. So we need all the logs on one side, or it needs to be a log equals a log, and we'll talk about that in a second. Okay, then you use the loop trick to rewrite the log in exponential form, and then you solve for x. So ideally what will happen is you'll have something like log base 2 of x equals 5. Okay, we have already done things like this. You do the loop trick. So we say 2 to the 5th is equal to x. Well, that would be 32 equals x. Okay? It's a little bit different if this x had something attached to it, and you'll see that in the examples here later on. Okay, so there is a special case. If we have something like this, log base b of x equals log base b of y. When the bases are the same and a log is equal to a log, the logs go away and we're left with just x equals y. So we would have x equals y. Okay? So sometimes this will be a number, sometimes this will be a y. I mean, it just depends. But this is the fastest way to solve a logarithm. And it happens occasionally. It doesn't always happen. Okay? So those are the steps. Make sure you write those down. Here we go. Example number 1. Alright, so solve for x. So in this case, there's nothing to condense. We only have one logarithm. So we're going to start by doing the loop trick. So I'm going to circle the 4 and do the loop. So I'm going to have 4 to the 3rd is equal to x plus 2. Now, we don't have a logarithm anymore, so all we're going to do is simplify. So 4 to the 3rd is 4 times 4 times 4. So 4 to the 3rd is 64 is equal to x plus 2. Now we just have a simple solving for x problem. I'm going to subtract the 2. So x is equal to 62. Okay? And that would be your answer. Alright? Pretty simple stuff. Let's see a second example. So in this case, we have 3 logarithms divided with an equal sign. So our first step was to condense. So we're going to condense these 2 logs first. They're being subtracted. So remember that division goes with subtraction. Multiplication goes with addition. Okay? So this is really log base 5 of x divided by 10 is equal to log base 5 of 3. Now, this is the special case because we have a log base 5 equaling a log base 5. If I had another number out here, I'd have to do something different, but that's not there. So at this point, I know that this log and this log are going to cancel. The 5's also go away, and I'm just left with x over 10 is equal to 3. Then I simply have something I can solve. So whenever you have something like this, remember you want to get the x by itself, so I'm going to multiply both sides by 10, so x is equal to 30. And that would be my answer. Okay, so if you end up with something like this, a log equaling a log in the same base, that's the fastest way to do it. Cross out the logs and you just leave whatever the standalone, or what the big number was, what was here. Okay? Example number 3. Now in this case, we have 2 logs separated with addition, and they're equal to a number, which means we're going to use the loop trick. So first I need to condense these. So I'm going to have log base 3 of x times x minus 8 is equal to 2. Now you can go ahead and distribute that if you want, or you can just leave it like this, it doesn't matter. We're going to end up distributing it no matter what. So I'm going to do the loop trick. 3 squared is equal to x times x minus 8. Now at this point I need to start simplifying, so I'm going to have it go up here. 9 equals x squared minus 8x. Now remember, whenever a squared appears, you have to solve it using quadratics because a quadratic has 2 solutions. So in this case I have to get this equal to 0, so I'm going to subtract the 9. Okay, so 0 is equal to x squared minus 8x minus 9. So then I can factor that. So I'm going to have an x. Alright, negative 9 would be, that'd be minus 9 plus 1 to get a negative 9 and a negative 8. Then I set them both equal to 0, or I switch the sign, so x is going to equal 9 and x is going to equal negative 1. Now, if you think back to parent functions, logarithms have a rule that you cannot have a negative logarithm. Okay? So, if I plug in a negative 1 to the x, log base 3 of negative 1 doesn't exist because there's no way to get 3 to any number equaling negative 1. So, the negative solution is extraneous, just like we talked about when we did roots, and so my answer is 9. Okay? So, that's how you work logs. Obviously, this last example is the hardest one because you end up with a squared. But overall, it's pretty simple. It's just using the loop trick and condensing, and you don't really even expand at all. Okay, so make sure you wrote down notes. Make sure you took good notes, at least wrote down the examples and the steps, and we will talk about this tomorrow. Have a good night.